So today we will see the very important concept in SQL, that is known as a normalization. So basically what we can say is a normalization. Let's start from there. So basically normalization is the process. Actually it is a process of effectively designing a relational database such that it avoids data redundancy. Now such that it avoids data redundancy. Now, can anyone tell me what is data redundancy? Okay, duplicate data, right? Now, entire row will be duplicate or few columns will be duplicate. Entire rows as well as few columns, right? So let me show you one example over here. So I have this denormalized data set, and this is a perfect example of data redundancy. So we have this column, right? Employee name, first name, last name, then email, then gender. Now if you see this customer name, customer id, customer name, customer phone, and customer address, so each of the employee is somehow connected with the customer. But over here if you see this record, seventh record, then is this an example of data redundancy, right? Because same record, same customer is repeating multiple times, it is known as a meaningless data, right? Meaningless data. Now in the same excel there will be again 50 is coming so many times, same customer, same phone number, same address, it is coming again multiple times. So this is also perfect example of data redundancy. So what is written over here can be referred to as a data duplication, right? This is known as a data duplication, right? Now even if some of the columns of a table are duplicated for multiple rows, so over here only these four columns are duplicated for multiple rows, right? Then we can treat them as a redundant data which can be avoided in a normalized database, right? Now designing a database, right? So process of creating the set of related tables which will store the data meaningfully as per the requirement. So suppose I want to design data from this particular table, then how we can design this database? So what we can do, we can copy this customer related information, right? All the customer related informations into another sheet over here. And then what we have to do, we can copy this entire thing, then go to the data, then we can select this remove duplicates, and we can do click OK. So 443 duplicates data has been removed. Now it is removed, right? And now what we can do, in place of this employee table, or we can say that employee information table, what we can do, we can copy up to over here, into another sheet. Why it is coming only? Okay, I think. So this is how we have removed the data, duplicate data, right? This is wrong. Let me delete this one. So this one we have maintained as a customer table, and then this one will be maintained as a employee table. So over here in the employee table, what we have done, we have added one additional column which is customer ID, and we have just mapped that customer ID from our customer table. Now one more way is there. Can anyone tell me what is that another way also we can do the normalization from the same table, this table only, this all these three table. This is the example, this is the sheet in front of you, and you can tell me from this Excel file only. Yeah, that I have already done. We have separated the table into the different sheet, but I have mentioned the customer ID over here in the into the employee table, right? So now this customer ID will be can be able to join with this customer ID. But what is another way that I am trying to tell you? Because it is normalization is not a fixed process. That this is how we can do normalization. Several people or several company will. It depends on person to person how they want to organize the data. So what one more way is there. Any idea? Yeah, perfect example. Yeah, we can create one more table, and this table we can name as a mapping table where we can do employee ID, and then we can copy this customer ID, and now what we can do one more thing, in this employee ID we can remove this customer ID. So now no need to mention customer ID in employee table. Now this is a mapping table, right? Now we can join with all these three table, and we can identify any of the data. So what do you mean by the? Yeah, okay. So over here in front of you, what you are seeing, that is known as a data redundancy. Why it is data redundancy? Because over here one customer is coming multiple times, and we are writing all the customer names several times, right? Solomon Hadril, we are writing multiple times. So this is, we can say, as a denormalized data. This one you can say as a denormalized data. But how we can do make it as a normalized data? So we can create multiple tables like employee table. We can create up to here in one table. Then we can create customer table. From over here to here we can create customer table. So that what I have done over here, customer table and employee table. Now normalization we can do with two different ways. One thing, we can mention this customer ID into the employee table itself over here, so that we will able to join this employee table and customer table with customer ID column. But now one more way is there. Some of the company are not maintaining one extra table that is known as a mapping table. So in the mapping table, you will find employee ID as well as customer ID right in the mapping table. So this is known as a mapping table. And now if I want information, then I can connect with all these three tables separately, right? I can join with employee table. Now I have to delete this column from here. I can join with employee table with employee ID and mapping table with employee ID, and then I can join again. this customer table with customer ID and mapping table with customer ID. So my problem will be solved. No, 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 no. We are always in data migration project. Mapping table will be always there, always. Definitely, it depends on company to company or person to person. We can create mapping table as well as we will mention a customer ID over here as well. That is based upon our choice. I will show you one more example in some time. Let's move ahead. So this thing we have seen process of creating the this thing also we have seen process of creating the set of related tables, right? So that we have done over here. We have relate from this entire data set we have created related tables, that is employee and customer. Now let's move ahead. Let's now show you one more example, then you will be clear. So now this is a denormalized data set I have in front of me. This is a perfect example of denormalized data set. So over here, if you see order information, order quantity, item price, total cost, order rate, status, then how we can say is a denormalized data set? Product code. So product information is also mentioned over here in the same table. This you can consider as one table, this entire thing. So product related information is also maintained over here. Then customer information is also maintained over here. Customer phone number, customer address, city, postal code. Then salesperson related information is also maintained over here. So in this one table, we have maintained all the information into the one table. So this is one more example of the denormalized data set. Now normalization can be done. Normalization can be done into mainly three different ways. That is known as a first normal form, second normal form, and third normal form. So most of the company is using up to maximum third normal form. Most of the companies are maintaining up to third normal form, not more than that, right? So first normal form. So let's see what is first normal form. Let's start with the first normal form. So over here I have already mentioned, like orders data is product data, customer data, and salesperson data. All are maintained in one sheet. Now what is first normal form? No, 1 minute. So this is the first normal form. So let's see. Every column and attribute need to have a single value. Over here it is written. Every column and attribute need to have a single value. So now can anyone tell me what is the problem over here? Means my question is how we can normalize this data set into the first normal form. What is the problem? Why only quantity column? Yeah, yeah, right. Item, yeah, item price also. Yes, it's right. Into a single column, multiple values are inserted, right? Over here in the product name, product price also, right? Then I think no other value. Now that is what I have written over here, every column and attribute need to have a single value, right? So how we can separate this into first normal form? So let's see over here. I have divided this 106 two times. Two times into over here. If you see this last two rows, so 4 comma 4 was there, right? Now 4 and 4 will be divided into two different rows. Then 780 will be provided to one row and 850 will be provided to another row, right? Then how 6520 is divided? So 780 comma 4. So let's take equal to 780 multiply by 4, 3120, and 850 multiply by 4, 850 multiply by 4, 3400. So 3120 and 3400 is coming, right? Now date will be coming, both the rows, shift will be coming in both the rows. At one row it will come prod 1004, another row it will come prod 1005. No, no, it is not repeated, right? Only this, the which column is repeated? Okay, no, it will take both the line item. Yes, yes. Now, now in one row buses will come and another row trucks will come, and one row 800 will come and one row 900 will come. So that is what it is coming over here. Now what will be the next rows? Sorry. What will be into the next row? So this all this column, alright. This all this coming column will be repeated two times, right? Because it is only one value. So all this column will be repeated two times in both the rows, right? So that is what it is doing over here. Same thing, right? So now what is the second thing? Now what is the second point? Each row should be unique. So over here, each row should be unique either through a single or multiple columns. Either through a single or multiple columns and not mandatory to have a primary key. So that is also it is satisfied, right? Only order number is duplicated. That is fine. That is fine. No problem. Because primary key is not mandatory. But now if you see order number and product code, combination is unique, right? So either through a single column or multiple column. Again, order number and product code combination is unique, right? So this is satisfying both our condition. Condition 2 means condition 1 and condition 2. So that is why it is known as a first normal form. In this entire table, primary key is not mandatory. If primary key is mandatory, then we cannot insert order number like this, right? If we create or a primary key on order number, then this can't become two times, right? This is not possible. So that is why not mandatory to have a primary key. So this is up to first normal form is very much clear, right? This is interview question will be asked to any level of experienced people like 5 years, 10 years, 2 years, freshers. Anyone can have this interview question in the interview. What is normalization and explain the different types or different versions of normalization. Then this one you can definitely explain, right? Now let's jump to the second normal form. So when we are moving to the second normal form, data must be there in the first normal form, right? Data should be must be there into the first normal form. That is by default. That is by default. Now, now all non-key attributes must be fully dependent on candidate key. Now let me explain this one. All non-key attributes must be fully dependent on candidate key. Now what is a candidate key? You need to understand that one. What is a candidate key? So set of columns which uniquely identify a record. Set of columns which uniquely identify a record. So can anyone tell me what should be the candidate key over here? It will be set of columns which uniquely identify a record. So what will be the candidate key over here? Yeah, perfect. It will be order number and product code. So now let me copy this data and copy this data. So now you can tell me, right? This combination of these two column is unique, right? Perfect, right? Combination of these two column is unique. So set of columns which uniquely identify a record. And table can have a multiple candidate key because there can be multiple set of columns which uniquely identify a record or a row in a table. So over here we can say that we can mention multiple candidate key also. Suppose we can mention, okay, we can mention order number and product name also, right? So this is also unique combination. We can mention multiple combination, that is what written over here. Multiple candidates key because there can be multiple sets. So over here multiple sets. One set is this one, another set is this one. Multiple sets can be defined as a uniquely identify a record, right? Multiple sets. Now what can be a non-key attributes? So columns which are not part of a candidate key or primary key. So now can you tell me from this one what are the non-key attributes? You got right, a columns which are not part of a candidate key. So non-key attributes are quantity, you can say as non-key attributes, item price you can say as non-key attributes, total cost you can say as non-key attributes, order rate you can say as non-key attributes, product price, customer number, phone number, all are. Please be on mute everyone. Every column other than Every column are the non-key attributes, right? You got it right. Hello. Okay. Now, now over here, what we are trying to do, we are trying to differentiate data into multiple tables in the second normal form. So how we will able to do it? So suppose we have this first normal form data is available, right? So order number over here up to from this one to up to here status we will be considered as a one table. So that what I have done over here. From order number, quantity, item price, total cost, order date and status. Up to that we have defined one table. I will tell you about this one later on. Now over here we need to identify each row uniquely, right? Over here we need to define the now read the third point. Every table should have a primary key and relationship between the tables should be formed using foreign key. This is the condition of second normal form. So over here we have two different 1006 are there, right? Over here we have two different 1006 are there. So what we have done? We have done this 06 to 07 to uniquely identify the record to create a primary key on this particular column order number, right? Yeah, we have manually changed it. Yes, yes. Yeah, then what you can do, you can create one more column over here, right? You can create one more column over here, like insert. I can do it. Yeah, 1, 2, 3, 4, 5, 6. Yeah. Yes, yes, yes. Now, up to here, we have created one table, then product related information like this one. So let me copy this one product related details. I think three columns are there, right? Only. So I am doing it over here in the next sheet for just for the explaining purpose. Now this will be my second table. But what is the problem over here? Can anyone tell me? Yeah, not only product code. Everything is repeated, right? So now what we have to do? We have to do remove duplicates. Now it is removed, right? So now this will become my second table. That is what I have done over here. In the product over here we have defined candidate key as well, which will be the combination of okay, this is the what I have explained earlier. Over here what I have shown you just now, product code, product name and product price. So for that one more table we have created and we have removed the data duplication so that we will able to create primary key on product code column, right? So now this will become my second table. Now what should we do? Now for customer number, sorry, for customer related information also we need to create one more table. But now let me create that one. Now can anyone tell me what will be the problem over here? Again same thing, right? In the customer table also there is a data duplicacy problem are there, right? So what we have to do? We have to select up to over this column, go to the data, remove duplicates, and we have remove duplicates, right? But now over one more thing is there. We need to can you we need to have a primary key column as well. So now which column we can create a primary key? But ideally, it is not a good practice to create a column, create a primary column on any name column, right? So what we can do, we can add one more column over here. Insert that column will be customer ID 1 2 3 4 5 6, right? So this is how we can create a add a primary key in a table, right? Now I can uniquely identify each record. So what if my another customer name will be this one, right? Then I cannot create a primary key column on the customer name, right? That is not possible. And same customer is resides in India city, right? Then it will be a totally new record, but we cannot create a primary key on name column. So that is how I have added one more column that is known as a customer ID. That only I have done over here. Then for orders. So let's we have I think orders data where it is. Okay. Okay, we have taken order data anywhere. Order data. Okay. First table is itself the order table, right? So we how many table we have created till now? Till now we have created. Okay, I will show you over here only. Till now we have created products table, customer table, and orders table, products table, and customer table, right? Orders table, products table, and customer table. We have separated three different tables, right? Now let's jump to the now what we have to do. Can anyone tell me now what we have to do? Okay, sale. No, currently we are not creating that sales table. That we will be creating in the third normal form. I will explain you at that time. How many tables we have created? Three tables, right? But now which table we have to create? I have explained you earlier also. How can we relate all these three table? Mapping table, right? Mapping table is yet pending. So again, I can tell you one more thing. Someone maybe, okay, let me copy this data here. This is my actually I want this table below map. So till now we have created this much of table. Now how we can create the mapping table? So one thing we can do, we can add we can add the customer ID column over here, and we can add product code column E here, and we can generate the respective value. But from my point of view, this is not a good practice. For better understanding and better practice purpose, what we can do, we can create totally a separate fresh table as a mapping table, in which we can copy order number. Let me go over here. What we can do, we can copy order number from here. This is my mapping table. I'm creating over here mapping table. Order number, then product code, and then customer. Okay, customer ID actually we have to take, right? And then customer ID. This is product code. Now over here it will be 4 5. Anything you can take. Don't know what is the exact value, and you can map 1 2 3 4 5 6. So this will become your mapping table, right? This will become your mapping table. So now your process of the second normalization form will be done. But now one more thing is mandatory. One more thing is mandatory, which is written over here in the third line. What is written over here? Every table should have primary key, and relationship between the tables should be formed using foreign key. Now can anyone tell me in which table we can have a primary key and which table we have can have a foreign key? Order name. Okay, yeah, this will become our primary key. Yes. Then customer ID will become our primary key. Then product code will become our primary key. And over here, maybe we can create one more table which can identify as a primary key because these orders are repeated, right? I think over here it is not repeated, but product is repeated. So this is, so we can create one more column, or you can give this one as a primary key and this one will be foreign key. This one will be foreign key, right? Over here it is repeated, but what if same customer ID is over here, right? 4 and 5. Just imaging like this way, right? Now this all this main table will have a primary key and mapping table should be always has a foreign key. This is our mapping table and we'll have always foreign key. So up to over here it is clear, right? So now what does it mean by the partial dependency? Let's understand that point. So if your candidate key is a combination of two columns, then every non-key column then every non-key column should be fully dependent on all the columns which form candidate key. So maybe you have not understand that point. If your candidate key is a combination of two columns, right? So over here our candidate key we what order number and product code. Then every non-key column. So over here every non-key column. Let me take the example of this one. So this sales contact last name, right? Sales contacts last name, then sales contact first name. Let's take the example of sales contacts last name and first name should be fully dependent on all the columns which form candidate key, right? So this you can say that this is not a fully dependent. Why? Because this non-key column, actually these are the non-key column, right? Sales contact last name, but it is dependent on the order number, but on the product number. Right now it is not dependent, right now it is not dependent. Why? Because product code itself is not present now over here in this orders table. Product code now itself is not present in this orders table. So how now we can say that it is, if there is a non-key column which depends only on one of the candidate key column, then this result is partial dependent. Now we can say that all these non-key column are partially dependent on the candidate key. How partially dependent? Because it is dependent on only single column, single candidate key, which is order number. But product code it is not dependent. We can easily identify that 10101 order is delivered by which of the salesperson. It is delivered by small Kawai U. It is delivered by Kawai U only. So it is partially dependent. It has nothing to relate with the product code. It has right now nothing to relate with the product code. So now for that purpose, what we are doing? We have to move to the third normal form. Now for that purpose, we have to move to the third normal form. Now let's see. Now let's see. Third normal form must be in the second normal form. So third normal form should be satisfy the condition of first normal form as well as the second normal form. Now avoid transitive dependency. Avoid transitive dependency. So over here, what is called as a transitive dependency? Suppose this entire table, or this we can say that entire table we are considering as a B. Entire table we are considering as a B. Then this one will be considering as a A. This product information we are considering as a A. And then this sales contact information we are considering as a C. C, right? Salesperson information we are considering as a C. Now what is written over here? Let's say you have table T which has three columns, namely A, B and C, right? So you can consider table T as this column, B, A, which is product related column, and C, which is sales related column. So now if A is functionally dependent on B, A is functionally dependent on B. So over here we can definitely say that this product table is functionally dependent on B. Product table is functionally dependent on B, and B is functionally dependent on C. B is functionally dependent on C. So this again, this B will is functionally dependent, not directly but functionally dependent on C. Sorry. Yeah. Yeah. Yes, yes. Row actually column will be remain the same. Yeah, maybe column will be also increasing. I will tell you, but this is a redundant data, right? This is denormalized and redundant data. So if we are moving this data into multiple tables, then definitely row will remain the, maybe row will be decrease, right? Not increase, because we are deleting duplicate data, right? In the product table we have deleted duplicate rows. Then in the customer table also we have deleted duplicate rows, and we have added few column, right? That is right. Now what is your question? Increasing the line item means, yeah, for this purpose actually I haven't added one more column, but that is also possible. What I have done for this, I am making 07. Okay. So, okay. So what I have told over here, if A is functionally dependent on B and B is functionally dependent on C, then we can say that A is functionally dependent on C. This is just like mathematical expression, right? B equal to C, then C equal to A. Then we can say that A equal to B. Same thing, right? This I have written over here in the words, and this is mathematical expression, right? So now over here, I furtherly up to here everything is fine. Order number, then product table will be also fine. Then customer table will also be fine, right? Up to here everything is fine. Now what we have to do? We have to further from this second normal form. We need to create one more table, that is a salesperson table, and that what is done over here, if you see below, one more table is created, employee id table. So over here, if you see this salesperson table, Perrier then Dominique is repeated multiple times. So 1 2 3 4 5 6, six records should be there, right? So employee table will be again, one more table is created, and for again one more primary key we have defined on the employee id column, e1 e2 e6. So this will be the base practice. Now mapping table will be slightly different. So previously in the mapping table, what are there? Order number, product code and customer id are there, right? But now we have to define one more column, employee id, as a mapping table, and that will be foreign key in this mapping table, and it will be remain primary key into this particular employee or salesperson table. So now your database is fully normalized. Now this table will have three foreign key, and this can be primary key and foreign key both. Order number will be primary key and foreign key both. Why? Because in the order table it is mentioned as a pk, right? Order table it is mentioned as a pk, and over here it is can be mentioned as a foreign key as well. Yeah. Yes, it is possible. We can check it practically. Let me check. We have this data, right? We have seen this example. Mm, 1 minute. Where is that customer table? 1 minute. Okay, over here it will be there. Okay, let me try. I'm dropping this customer table. Let me create totally fresh table. 2907, right? Now I'm creating a primary key on this customer ID, right? Now let me copy this one. Let me create one more table. This is that is, but I cannot create one more table, right? 1 minute. Alter table. This one. Right. One more column we need to add. Cost CID integer. Okay, I think this way is possible, but you are telling same column, right? Okay, I will try that practically and will let you know. But this one will be possible. Let me try. Okay, in the same table, I have created the foreign key, right? Okay, I will try that and let you know tomorrow. Yeah, yeah. Here I have. Yes, yes, right. Yes, yes. Or one thing what we can do over here in the relationship table is, if that is the problem, then one can thing also we can do is we can create one more column. This will become our primary key, and this will become our foreign key. Now perfect, right? This is how we are creating the mapping table. No, no, we are not losing any control. We are not losing any control. No, no. Hmm. No, no. Actually, we cannot lose control. How? Because that is why the main concept of this come into the picture. Why joins are there? Why joins are there? Joins are because of this purpose only, right? Now we have one table, order table, product code table, customer table. Okay, how many tables are there? Orders table, customers table, अरे, products table, employee table, and mapping table. Now we have one mapping table, and we can do join of any number of table, right? We can do join of orders table with mapping table, then customer table with mapping table, products table with mapping table, employee table with mapping table, and we can connect all of the information which is required. Ac- no, no, actually whenever we are doing the daily sales, okay, I think once I will explain you this one, at that time you will be more idea, but this we will take it on tomorrow. This insert, this is transaction data only. You are talking about daily sales means transaction data only, right? So we will get to know once we will. I will explain these three thing. But in the daily sales also we will have a normalized data only, right? Mostly we do not have a, like, do we have all the details like this order, product, customer? in one table in our company when we are working in the real time environment. We have this kind of data? We do not have, right? We do not have every data in one table only. We do not have, right? Yeah, this will be the then it will be the same process. We what we have to do. Where okay, I think it is written over here. Then what you have to do? You have to restructure. You have to restructure your database. This is what you have done in the small data set. That same thing you have to do to the large data set. Only that thing will be changed. But again, we will see further tomorrow. Maybe you will get more idea tomorrow when we will understand this thing. But this is what the first normal form, second normal form, and third normal form will be work. Up to here, they will ask that let's explain up to three normal form. Then same thing, or you can give the same example. You can give. They will impress with your if you explain whatever I have explained you today in very detailed way, then they will definitely impress with your answer. So let's keep up to here. Everything is